Hi, and welcome to lesson 16.1. This is all about representing proportional relationships. And our essential question is, how can you use tables, graphs, and equations to represent proportional situations? All right. We have an explore activity here. Representing proportional relationships is this table. In 1870, French writer Jules Verne published 20,000 Leagues Under the Sea. And one of the most popular science fiction novels ever written. One definition of a league is a unit of measure equaling 3 miles. All right, so we're going to first complete a table, and we have our distance in leagues and the distance in miles. So 1 league, as was just mentioned, is 3 miles. That was right up here. And so if we double the distance in leagues, we double the distance in miles. And if we triple it, we triple the distance in miles, which is 18. And so let's look at this. 3 going into 36 is 12 times. So we multiply 1 times 12. And that's how we get 12 there. And so 20,000 leagues is going to be 60,000 miles. That's quite a bit. What relationship do you see among the numbers in the table? Okay, well, in our table here, we see that 3 is 3 times the size of 1, and 6 is 3 times the size of 2, and so on. So every number in the bottom row, this bottom row, is 3 times the number in the top row. Okay, from each column in the table, find the ratio of the distance in miles to the distance in leagues. Write the ratio in simplest form. Well, as we have this 3 over 1, that's equal to 3. And then we have 6 over 2. That's also equal to 3. I could say 3 over 1 for each of these ratios. 18. 18 over 6 is still 3. And 36 over 12, that is 3 as well. And 60,000 divided by 20,000, that's still 3. And so what do you notice about all these ratios is they all equal 3 over 1, or 3. So if we reflect, if you know the distance between 2 points in leagues, how can you find the distance in miles? You just multiply the distance in leagues by 3. Distance in leagues by 3 gets you the distance in miles. And now if we go the other direction, if you know the distance between 2 points in miles, how can you find the distance in leagues? Well, we divide the distance in miles by 3. Great. Let's go on to the next page. Representing proportional relationships with equations. The ratio of distance in miles to the distance in leagues is a constant. This relationship is said to be proportional. A proportional relationship is a relationship in which between two quantities in which the ratio of one quantity to the other quantity is a constant. A proportional relationship can be described by the equation in the form y equals kx, where k is the number also known as the constant of proportionality. K, constant. I don't know why they chose K to stand for the word letter K to stand for the word constant, but they did. So we're going to use that. And then what's also super important is to find the value of K, you have to take a Y value divided by its corresponding X value. Okay. And let's bring this in a little bit closer, and I'll zoom in a little bit. Okay. So again, K is a Y value divided by its corresponding X value. So we look at example 1. Megan earns $12 an hour at her job. So we're going to show the relationship between the amount she earned and the number of hours she worked. That is a proportional relationship. Then we're going to write the equation for that relationship. And step 1, we're going to make a table. So if she works 1 hour, she gets paid $12. 2 hours, $24, and 4 hours, $48, and so on. And we get that 96 because it's 12 times 8. So everything in the second row is 12 times the size of everything in the first row, because she earns $12 an hour. And if we make if we divide the amount she earned by how many hours she worked, we're going to get 12. So the ratio is definitely proportional throughout. And anytime you get paid hourly, it's going to be proportional. So we're going to write our equation. And y equals kx. Now that k is the unit rate. In fact, what I should do is write this here. K right here is also known as the constant proportionality, and that's the same as the unit rate. So that is also the unit rate. Okay, so that's pretty important. So as we have the unit rate right here, $12 per hour, that is our K in our y equals kx equation. So that's why it's y equals 12 times x. And we would know that any y value is 12 times the size of any x value. And that's true in our table. Our y values are 12 times the size of any corresponding x value. And I say corresponding because the corresponding values, they match up in the columns. Okay, so here, 15 bicycles are produced each hour at the Speedy Bike Works. Show that the relationship between the number of bikes produced and the number of hours is a proportional relationship. Well, it's done each hour, so it's going to be proportional. And then write the equation. Well, what I could do is I could make a short table. So x is hours and y is bikes made. And if we have one bike, that's going to take 15 hours, and two bikes is going to take 30 hours. That's a terrible 30. And three bikes is going to take 45 hours, and so on. So the y values are 15 times the size of their corresponding x values. And so there, y is equal to 15x. And we could get that 15 by taking a y value divided by its corresponding x value, a y value 15 divided by 1. Or you can take 45 divided by 3. It's going to be the same thing. Okay, next. We have representing proportional relationships with graphs. Okay, you can represent a proportional relationship with a graph. The graph has to pass the line 0, 0. It has to be a straight line that passes through the origin, which is 0, 0 on the graph. And here is such an example where it's a straight line that passes through the origin. In our example 2, the graph shows a relationship between the weight of an object on the moon and its weight on Earth. Write an equation for this relationship. Use the points on the graph to make table. Okay, so we have Earth and Moon, and so Earth is X, the Moon is Y, and we can see Earth is the X-axis and the Moon is the Y-axis. And let's see. Oh my God. Well, I thought they were going to say it right here, but we're going to figure it out. The moon's weight divided by the Earth's weight. The moon's weight is 1 and the Earth weight is 6. So that means it's 1/6. That is our constant proportionality. And we can see it's constant throughout. It's always 1/6. That's why it's called a constant of proportionality, because it doesn't change. It's constant. And so our constant of proportionality is 1/6. And we get that by a y value divided by its x value. It could be 3 divided by 8, but this is clearly going to be the easiest choice. And remember, the constant proportionality is a y value divided by its corresponding x value. Okay, so there's our equation, y equals kx, where k is 1/6. There you go. Done deal. There's not much more to say about it. Here's the graph shows a relationship between the amount of time that a backpacker hikes and the distance traveled. Okay, so here we go. And what does the point 5, 6 represent? Well, 5 is this is called an ordered pair, and the first number is the x number, and the second number is the y number. So 5 is 5 hours. So 5 hours. And 6, that 6 right there is the distance traveled. So you travel 6 miles hiked in 5 hours. What's the equation? Well, it's y equals kx. And so to get this equation, it'd be y equals kx, where k is a y value divided by its corresponding x value. So we take a y value such as 6 and divide it by its corresponding x value, which is 5. 6 over 5. I could have taken this, what is that, 12 over 10? But that simplifies to 6 over 5. So I'll just take the smaller numbers, and there it is. Our equation for the proportional relationship of the hiking. And so this is what you need to know about proportional relationships, graphs, y equals kx, constant of proportionality, and in the end, representing proportional relationships. There you go. Thank you very much for watching.